So here's the deal. Proteins are assembled and squirted into the rough ER by the ribosomes. So in the video, when you saw this going on, this is a ribosome. And here's the ticker tape kind of thing that carries the genetic code that tells it what protein to make. So it's squirting the protein into the endoplasmic reticulum, where it's then further processed and stuff. Okay. And so I know it's just getting on. Uh, Again, you get the ribosomes embedded on the rough endoplasmic reticulum. The smooth endoplasmic reticulum doesn't have ribosomes. I'm not going to make you even write that one down. But you have the smooth ER, which is more on the outside of it. The rough endoplasmic reticulum is closer to the nucleus, so you got easy access from the genetic material. Okay, proteins are packaged to be sent then. Now, we got another wild word, Golgi complex. Now, this one, I apologize, it actually has three totally different names. Sometimes it's called Golgi complex, sometimes it's called Golgi bodies, and sometimes it's called the Golgi network. But we'll just call it, I don't know, either Golgi bodies or Golgi complex. Probably show up either way. But they were discovered by a guy named Golgi. That's where the word comes from. What it is really, it's kind of like it breaks the ER, the endoplasmic reticulum kind of breaks off, and it's using it to sort of transport and further process to take things to the outside of the cell. Which is, by the way, what you're seeing in that video. When you see this, what's going on then is these proteins that are being manufactured are being delivered to the outside membrane to be embedded in the outside membrane. So that's what this guy is doing. He's hauling a big sack of proteins out to the outer membrane of the cell. Alrighty, let's see. So the Golgi complex or Golgi bodies, go ahead and write that down. And I don't even feel like making you write down the what it does. It processes and packages complex proteins for distribution. Okay, so the proteins are continuing to still be made. They're not being made by the genetic code, but they're folding up on themselves to get the shape that they need. Okay, discovered by a guy named Golgi. That's what the name is. And so, this is what it looks like under the microscope. This is really why I picked that particular picture. It's pretty cool. Really good microscope. Here's a black and white picture. Here's what it looks like under the microscope. So it has these vesicles here, and it has this sort of shape where it's like one kind of pancake thing. And in the video, looks like this, right? In that computer animation made by Harvard. And here you have these sacs being carried along the cytoskeleton, these protein strands. And here's the Golgi complex. And so basically what happens is the genetic material comes from the nucleus and it goes to the ribosomes to make the proteins, and then the proteins are processed further and they will travel to where they're needed in the cell or to the outside of the cell. Okay? There's a lot of stuff I'm going to, like I said, wait till you're in college to learn about what a lysosome is or things like that. We can worry about that later. All righty. I think we got plenty of vocabulary words for the day, don't you? Okay, let's do kind of a reverse and backwards order. What's this thing called? Say it out loud. Golgi complex or Golgi bodies, right? And, I was pointing to the wrong one. This is the one I meant. This one here is the smooth what? Endoplasmic reticulum. Please say it when I cue you. I know you might feel like, well, I'm just sitting here in my bedroom doing this. Just, say it. It'll help you learn. And then this one is called the rough what? Endoplasmic reticulum. These little dots are called what? Ribosomes. And then the nucleus is where the genetic material is. And the nuclear envelope is what it's called sometimes. I'm going to kind of leave that one out, although nuclear membrane or nuclear envelope. I'll tell you this, though. I'm going to leave it out just because I'm going to pick and choose to only forget, try to narrow it down as much as I can. The difference between the nuclear envelope and the membrane outside is that it's a double layer thick, so it has these kind of holes in it. And so the messenger RNA can actually be transported out. Things can leave the nucleus, these signals. The nucleus has a way to get the signals to the cell. So it's a little bit different. And I'll just tell you that now. I'm not going to have it on a test or anything. There's also this other thing called the nucleolus, and it's where ribosomes are made. And again, just to try to limit the number of new words you have, I'll tell you that's there. But if you see a diagram that says, oh, nucleolus, oh, you didn't learn that. Well, that's, like I said, I'm trying to keep it more bite-sized, if you don't mind.